let's see the question 2 in homework 8. Firstly, we know that the probability of n equals to k in t1 to t2 equals to the e to the power minus lambda times t2 minus t1 times lambda times t2 minus t1 to the power of k and divide by a factorial of k, and we build another stochastic process xt equals to 1 if n is an odd number in 0 to t and minus 1 if n is an even number in 0 to t. For the first question A, we want to find the probability of xt equals to 1, so which is the probability of n is an odd number in t2 in 0 to t, and this equals to the probability of n equals to 1 plus the probability of n equals to 3 and plus so on. So this equals to the sum of k equals to 0 to the infinity of e to the power minus lambda t times lambda t to the power 2k plus 1 divided by the factorial of 2k plus 1, and this equals to the e to the power minus lambda t times the sum of k from 0 to infinity of lambda t to the power 2k plus 1 divided by the factorial of 2k plus 1. And we consider Taylor's series of e to the power x, and this equals to the sum from k to equals to 0 to the infinity of x to the power k divided by k factorial, and so we get the e to the power lambda t equals to the sum of k equals to 0 to infinity lambda t to the power k divided by factorial of k, and e to the power minus lambda t equals to the sum of from k equals to 0 to infinity of minus lambda t to the power k divided by k factorial. So we get e to the power lambda t plus e to the power negative lambda t equals to the 2 times the sum from k equals to 0 to infinity of lambda t to the power of 2k plus 1 divided by 2k plus 1 factorial, and this equals to 2 times the probability of xt equals to 1 divided by e to the power negative lambda t. So we know that the probability of xt to equals to 1 is 1 minus e to the power negative 2 lambda t divided by 2. And for the question B, we want to find the e of xt, so this means 1 times the probability of xt equals to 1 and plus minus 1 times the probability of xt equals to minus 1. So this equals to the 1 minus e to the power negative 2 lambda t divided by 2 minus the 1 minus the probability of lambda t equals to 1. So the result is negative e to the power negative 2 lambda t. And for the third question, question C, we want to find the autocorrelation function or t1, t2. So if t1 is smaller than or equal to t2, we get the autocorrelation function equals to the e of xt1 times xt2, and this equals to the probability of xt1 times xt2 equals to 1 and minus the probability of xt1 times xt2 equals to minus 1. So this is equals to the probability n is an even number in T1, T2, and minus the probability of n is an odd number in T1, T2. So we get the probability is 1 plus the e to the power negative 2 pi times T2 minus T1 divided by 2 and minus 1 minus e to the power negative 2 pi times T2 minus T1 divided by 2, and the result is e to the negative 2 lambda times T2 minus T1. As for the T1 larger than T2, we get the autocorrelation function is this, and we sum this result up, so we get auto correlation function equals to the e to the power negative 2 pi times the absolute value of T1 minus T2. And for the question D, xt is not WSS because the e of tx equals to the negative e to the power minus 2 pi t, and this is a function of t is not a constant, so the xt is not WSS.